Good day everyone, this is the group of artistic mathematician, truth table leaders, and future illegal loggers. This is the group 7 and this compiled video consists of different examples of arguments in mathematical logic. So what are we waiting for? Let's get started. Good day everyone, I am Kirby Jay Rodriguez and the first argument is I will buy a new costume for the party or borrow a dress to my friend. If I don't buy a new costume and borrow a dress to my friend, I don't need to spend my money. I bought a new costume and spent my money, therefore I didn't borrow a dress to my friend. Let K represent the statement I will buy a new costume for the party. I represent borrow a dress to my friend, and R represent I don't need to spend my money. So types of statement and their connective symbols. Connective AND symbol. Type of statement is conjunction. Connective OR, its symbol. Types of statement is disjunction. Connective NOT symbol. Types of statement is negation. Connective if, then, its symbol. Types of statement is conditional. If and only if, its symbol. And types of statement is biconditional. So our first premise is K or I. Negation K and I implies negation R is our second premise. K and I is our third premise. Therefore, negation I is our conclusion. So there are 3 statements. So we will be having an 8-row table. So let's proceed to our truth table. So we have 3 variables, K, I, and R. So I organized them for truth and for false. In second column, 2 true and 2 false. True, false, true. And R in the third column is true, false, true, false, true, false, true, false. So let's proceed to our fourth column, which is negation K. To get a negation K, it is in the opposite of course, the K in the variable. So the value is true, so the opposite of true is false. False, true, of course, false. False is true, true is, and then same to other variables, which is negation I. True is false. True is false. False is true, opposite of the given value or the given. So the seventh column is the first premise, which is K or I. So we are going to get the value of the K or I. So we are going to see the value of the K and I in the first or the second column. So true, if the value has true, of course the value of the K or I is also true. But if it has false, same false, the value of the K or I will be false. So let's proceed to our eighth column. So the eighth column is to get the second premise is we are going to find the negation K and I. So to get the negation K and I, we're going to see the value of the column of the fourth column, which is negation K, and the second column, which is I. So the symbol of the eighth column is in AND. It is if true, the answer is true. If false, the answer is false. If true, false, or false, true, the answer is false. So we have false, 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 true, true, and false, false. So the next column is a negation K and I implies negation R. So the next column is to get the next one is implies algebraic conditional. So false false is true, false true is true, false false is true, false true is false. But if it is true false, it is a false statement as a false value. True true true. So next column is our third premise. So K and I. So true true is true, true true true, true is false. So the same in the other value. Next is our conclusion or the negation I. So it is the opposite of true is false, false, true, true, false, false, true, true. As there are no premises that is true, 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 and the conclusion is true, so our statement is invalid. That's all. Thank you.
Hello everyone, this is a conditional statement example. Let P represent the statement I will ride a ferry, and let Q represent the statement I will reach my destination quick. The argument, if I ride a ferry, then I will reach my destination quick. I did not ride a ferry, therefore I did not reach my destination quick, is given in symbolic form of P implies Q, which is the first premise, and not P, which is the second premise, and the conclusion, not Q. Next, it's truth table. The first column is the first statement P, which has the possibilities of true, true, false, false. While the second column is the second statement, which has the possibilities of true, false, true, false. Next column is the first premise P indicates Q, which is derived from the possibilities of P and Q. We have true, true is true, true implies false is false, false implies true is true, false implies false is true. Next is the second premise, not P, which is a negation of P. We have false, false, true, true. And the conclusion, not Q, which is a negation of Q. That is false, true, false, true. We can see here that there are premises that is both true and the conclusion is true, and that makes an argument valid. But we can see here that there are premises that is both true but the conclusion is false, and that makes this argument invalid.
Hello, Ibañez Jr. I'm here to determine the validity of the following argument, whether it is valid or invalid. I will be using S and G to represent the simple statement. The statement is, if you don't study, then you will not get good grades. You studied, therefore you will get good grades. The first sentence, not S, will be don't study, and not G will be then not good grades. The second sentence is S, and our conclusion is G. We will now form the symbols to make a truth table. Not S implies not G is our first premise. Our second premise is S, and our conclusion will be G. We multiplied the two variables by 2, and it is why we have 4 rows. Now we'll make the table. Not S has T, T, F, F. Not G has T, F, T, F. The third column, not S implies not G, has T, F, T, T. So it is a conditional statement. In order to identify the truth value of the third column is to look at not S and not G using the conditional method. S has F, T, T, T. In order for us to determine the validity of an argument, we must look at the first and second premises, and then the conclusion. if it has a true value. G has F, T, F, T. Now, we will look at the rows. First row is T, 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 F, F. The second row, T, F, F, T, T. The third row, F, T, T, F, F. And the fourth row is F, F, T, T. The fourth row has all truth value. That is why this statement is a valid argument. Thank you for listening.
I will discuss in this video how to determine whether an argument is valid or invalid using the truth table. The following argument is an example of a conditional statement. If the exam is easy, then I will get a high grade. I did not get a high grade. Therefore, the exam is not easy. How do we determine if this statement is valid or not? First thing that we should do is to write the argument in a symbolic form. It means that we're going to assign a variable or a letter for each component of the premises. Let P represents the exam is easy and let R represents I will get a high grade. P implies R is the first premise, not R the second premise, and the conclusion is not P. In the truth table, the first column is P with the possibilities of true, true, false, false. The second column is R with the possibilities of true, false, true, false. The third column is the first premise, P implies R. So we have true, true is true, false is false, false, true is true, and false, false is true. The fourth column is the second premise, which is the negation of R or not R, and we have false, true, false, true. The last column is the conclusion not P, and we have false, false, true, true. We can see that there is only one row that contains all true premises and true conclusion. So, the argument is valid.
Good day everyone, I am Sherlyn Vega and now I am going to determine the validity of the following arguments, whether it's invalid or valid. So we have here a simple statement. If I do the dishes, then my husband will be happy with me. I won't do the dishes, therefore my husband won't happy with me. So this is our simple statement. So we are going to our symbolic form. As you can see, we have here our two premise. Our first premise is the implies H. So this is our first premise. Our second premise is not D. So this is not D, the negation of D, and our conclusion, not H, the negation of H. So this is our first premise, second premise, and our conclusion. So here, as you can see, we have two variables. This is we multiplied them. 2 times 2 equals 4 rows. So this is our rows. This is our truth table. We use this so we can find, or so we determine if this is statement is invalid or valid. So here we have here the H, the implies H, not D, not H. So first, D, true, true, false, false. H, true, false, true, false. So this is our first premise. So we are going here if true and true is true, if true and false is false, and false and true is true. False and false is true. So this is our first premise, and our second premise is the. So this is conditional statement where the "the" is hypothesis and "each" is our conclusion. So we have here false, false, true, true. And the last is our conclusion. If true and false is false, false and false is true, true and true is false, and true and true is true. So this is the last. So we need to look this if this our simple statement is invalid or valid. We look our first premise, true, true, false, and our second premise, true, true, false. And now we look or we see the our conclusion, T, true, true, false, true, true, false. So this is our conclusion. Our conclusion is false. So that's why this simple statement is invalid. Thank you.
Good day everyone, this is Virgel Quiboy reporting, and now I'm here to determine the validity of my argument, whether it's valid or invalid. But first, I'm going to read my argument. I'll take a medicine or I'll go to the center for a checkup. If I take medicine, therefore, I don't have to go to the center for a checkup. And now, I'm going to use the A and B as a symbol to determine my statement. And let's proceed to our symbolic form. The first premises is A implies B, and the second is not A, and the conclusion is not B. So since we have two variables and we're gonna multiply it by 2, so we have 4 rows now. In order to construct the truth table, and let's proceed to the table. The first column is A, which is the true, which is true, true, false, false. And the second is B, it is true, false, true, false. And the third, which is our first premises, A implies B, is true, false, true, false. If the first column is shows false and the second is false, now our first premises, which is A implies B, is true, because the base rule of conditional state when both are false. And the fourth is the second premises, which is the not A, is shows false, false, true, true, and the conclusion is false, true, false, true. To identify our argument where it is valid or invalid, let's take a look in our premises, which is in this part shows the truth, but our conclusion is false. Now the argument is invalid. Thank you.
My name is Laurence Cajutol, and for today, we will determine if my arguments is valid or invalid. First, I will read my argument. If the ticket is cheap, then I will buy it. The ticket is not cheap or expensive, therefore I will not buy it. First step is we will find the first premise there is if the ticket is cheap. This is our first premise and we will substitute it. We will substitute this as a symbols, a small letter C. Then second step is we will determine or we will find the second premise, which is I will buy it, and we will substitute it as a symbol, so it will be B, small letter B. Then this will be the conclusion of my arguments. Therefore, I will not buy it. Then we will construct now in the truth table. So the constant of our first premise is TTFF. Then the B, TFTF. So C implies B. We will look at this first row and second row. This is the C and B. So truth, so it will be the answer will be truth. Letter T. Then TF, and the second row is false. The first row is truth, so it will turn into false. False, truth. The second row is truth, so it will be truth because as a law of imply sign, this is the imply sign. So the rules of imply sign, if the second column is truth, the answer will be truth. Even if the first row is false and the second row is truth, the answer will be truth. And lastly is FF. So as the rule of implies, false to false, the answer is truth also. Then next is imply C. When we say implies, this is the imply sign. Imply signs will negation. This is negation. Opposite of C, this is truth, then it will be false. Truth, the opposite of truth is false. Then false, the opposite of false is truth. Then the opposite of false is truth. Then now we will find the negation of B. Negation of B, truth, the opposite of truth is false. F, T, F, and F, T. So how we will determine if the truth table is, or our argument is valid or invalid by finding the way of, or by observing this table. So as we see, C implies B, truth, and negation of C, truth, conclusion is truth. So therefore our arguments is valid. Remember that if the third row is truth and the second row is and the fourth row is also truth, then the conclusion is truth. Therefore, our arguments is valid.
Hi all, good day. I am This was Sajor. Now, I discussed how to determine the validity of the arguments, where to know that the arguments are valid or invalid. This is my argument. If you wear a tinfoil hat, then aliens cannot read your mind. You wear a tinfoil hat, therefore aliens cannot read your mind. You wear a tinfoil hat is our statement P, and aliens cannot read your mind is our statement Q. P implies Q is our first premise. Our second premise is P, and Q is our conclusion. I write these arguments in this form to know that this is our conclusion. Now, we go to our truth table. First column is P. P is true, true, false, false. Second column is Q. Q is true, false, true, false. Third column is P implies Q. The symbolic form implies is a conditional statement. So, P implies Q is true, false, true, and true. Fourth column, P implies Q or P is true, false, false, false. So we go to our conclusion. Our conclusion is P implies Q or P implies Q. This column refers to 1 and 4 column. P implies Q or P implies Q is true, 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 and true. So, 4 and 1 column or P implies Q or P implies Q are valid because all the conclusion statement is true. So, the argument is valid. This argument is a direct reasoning. Thank you and God bless.